Hello everyone, welcome to our group project for ECG565 Highway Engineering. This is our team members that conduct a study on road safety features in UITM SHAH LAM. The first test is skid resistance test. The objective is to measure the frictional resistance between the rubber slider and pavement surface under dry and wet conditions. This is the procedure of conducting the test. Rough surface. 1. Set up the apparatus and centered the bubble. 2. The rubber slider was adjusted to achieve the required contact length with the pavement surface. 3. The pendulum arm was released, allowing the rubber slider to slide across the pavement surface. 4. The pavement surface was wetted using water to stimulate wet road conditions. 5. The pendulum arm was released again, allowing the rubber slider to slide across the pavement surface, wet surface. The test was repeated 3 times to get the average result. The test will be repeated for medium surface, dry and wet condition. This is the result that we obtained from the test. As you can see in the table, the grip always drops when the road is wet. Basically, skid resistance is what keeps cars from sliding and prevents accident. Because of the presence of the water lowers the friction between tire and the pavement, the results show that dry surfaces offer better skid resistance. The 3 tests conducted were largely consistent, suggesting that it's thrust-worthy. The results demonstrate that skid resistance is significantly affected by both moisture and pavement condition. For conclusion, pavement condition has a significant impact on skid resistance. The findings confirm that due to reduced friction between the tire and the road surface, the skid resistance decrease. As a result, maintaining good pavement surface conditions and proper drainage is critical to improving road safety and lowering the risk of skidding, particularly during wet weather. The second experiment that was conducted is sand patch method. The objective of this test is to determine the mean texture depth, MTD, of the pavement surface, which indicates the roughness and ability of the surface to provide water surface paths. This is the procedures of the test. Rough surface. The pavement surface was cleaned before testing. Measure 20 ml sand using measuring cylinder. 20 ml of sand was poured onto the pavement surface. The sand was spread evenly using a circular motion until it filled the surface voids. Repeat for wet condition. The diameter of the circular sand patch was measured. Medium surface. Repeat for medium surface for dry and wet condition. This is the result obtained from the test.
The rough pavement exhibited a higher average texture depth, ATD, than the medium pavement under both dry and wet conditions. Under dry conditions, the rough pavement recorded the highest ATD, 1.92 mm, indicating a coarser surface texture. After wetting, the ATD of the rough pavement decreased slightly to 1.84 mm, while the medium pavement increased from 0.94 mm to 1.45 mm. Surface texture influences skid resistance, tire grip, and water drainage. A higher texture depth generally provides better friction and reduces the risk of hydroplaning during wet weather. The observed differences are likely due to variations in surface roughness and aggregate exposure between the 2 pavement conditions.
For conclusion, the sand patch test successfully quantified the macro texture of the pavement surface. The rough pavement demonstrated greater texture depth, indicating better skid resistance and surface drainage. Overall, the sand patch method proved to be an effective technique for evaluating pavement surface letter. The last test is the drainage performance. The objective of this test is to evaluate the ability of the pavement surface to drain water and reduce water film thickness, which affected skid resistance. This is the procedures of conducting the test. Rough surface. 300 ml of water was measured and applied onto the pavement surface. The stopwatch was started when water contacted the surface. The time required for water to drain through or flow across the surface was recorded. Medium surface. Repeat for medium surface. This is the results obtained from the test.
The outflow meter test was conducted to evaluate the surface roughness by measuring the time taken for a fixed volume of water to flow out. Surface A recorded a flow time of 7 seconds, resulting in a flow rate of 4.286 times 10 to the power of 4 cubic meter per second, while surface B recorded 7.98 seconds with a flow rate of 3.76 times 10 to the power of 4 cubic meter per second. Since water flowed faster on surface A, it indicates lower resistance and a smoother surface. In contrast, the slower flow rate on surface B indicates higher surface roughness. In conclusion, the outflow meter test shows that surface A is smoother, while surface B is rougher. A smoother surface allows water to flow more quickly, whereas a rougher surface increases friction and reduces the flow rate. Therefore, the test successfully distinguishes the difference in surface texture between the two specimens. The location and safety measures for all experiment. Thank you.